welcome in online series of machine design. Myself, Goswami. In this lecture, we will discuss or we will continue the gearbox different types of progression laws. Okay. So in first lecture or in previous lecture, we have seen that different types of progression laws used in gearbox to change the speed, okay, or to according to your requirement of torque. For example, in hilly areas, you require more torque to run the same vehicle as compared to running the same vehicle on plain road. Okay, so this is the basic difference. So according to that requirement, gearboxes are required. Okay, so for to fulfill that requirement, we have used different types of laws. Okay, so why progression laws are used? So why progression laws are used to find out different types of speed steps and find out different relation between any two types of speed steps. Okay, so there are basically three types of progression laws are used. First is your arithmetic progression, that short form is AP, and second one is your geometric progression, short form is GP, and third one is your harmonic progression, so that is known as HP. Okay, so in the previous lecture we have discussed about arithmetic progression. Okay, so in this lecture I will continue geometric progression. So geometric progression is generally ratio. You can see here geometric progression ratio, okay, or speed ratio. So geometric progression ratio is generally denoted by phi, and it should be constant. Means the ratio of any two successive speed should remain constant. And we have seen that in arithmetic progression, the difference between any two successive speed should remain constant. So that's known as your simple arithmetic progression, right? In geometric progression, the ratio of any two successive speed should be remain constant. Okay, so that's known as your geometric progression. Next is your range ratio. So range ratio means whatever amount of speed steps you are used in that case. So ratio between maximum speed and minimum speed is known as your range ratio. Okay. So different spindle speeds may be vary from n minimum to n maximum. Means minimum rotational speed to maximum rotational speed. Okay. And diameter to be machined is denoted by dk, and difference between any two successive diameter of your workpiece is known as your range of diameters. So what is speed ratio? I have already explained it. Speed ratio is equal to a ratio between any two successive speed, and in case of geometric progression, that should be remain constant. So speed ratio is equal to n2 divided by n1 is equal to n3 divided by n2, and so on. So last is maximum speed 2 divided by next to maximum speed, means last speed divided by second last speed. So you will get the speed ratio. Okay. Now what is the geometric progression ratio? In geometric progression ratio, range ratio. So range ratio is basically I have already explained. It is the ratio between maximum speed to the minimum speed. So Rn is equal to Nz divided by N1 is equal to, you can factorize or factor, means this is your maximum and this is your minimum. So we can write down it maximum divided by second last maximum speed, okay, multiplied by then maximum, for example this is your last. So last speed divided by second last, then third last divided by fourth last, and so on. So finally we will multiply it by second speed divided by first speed. So you will get the range ratio. So we know what is the your you will get this value. So finally, what is your nz divided by nz minus? So this is your speed ratio. Similarly, this is also nz minus 1 divided by nz minus 2 is also your speed ratio. Similarly, n3 divided by n2 is the speed ratio, n2 divided by n1 is your speed ratio. So now we will multiply all speed ratios. So we will get this Rn is equal to 5 z minus 1. So number of speed steps minus 1 is give your range ratio. So range ratio is equal to speed ratio the power number of speed steps minus 1. So you will get the range ratio. So by reversing this condition, you will get the speed ratio. So speed ratio is equal to range ratio की power 1 upon z minus 1. Okay, if one factor will be given, so you can find out another one, and by finding out one factor, you can find out the another one. So range ratio, yes. Second thing is your range ratio is constant for different types of machines. Okay, so range ratio for lathe machine varies from 40 to 60. For milling, it varies from 30 to 50, and for shaping, it's vary from its value fixed. It's 10, and for drilling, it varies from 20 to 30, and for grinding, it varies from 1 to 10. Okay, so by using, yes, next is which type of blocks generally used in gearbox. Okay, so by using geometric progression, the speed is reduced uniformly in different type of your stages. Okay, so generally we prefer that, or we will use GP, geometric progression, for your reduction or generally in gearbox. Okay, next is your preferred number series. So what is preferred number series? So its definition is fixed. Generally in gearbox design, set of preferred steps, ratios or preferred number is used to obtain the series of output of gearbox. Okay, so this is the fixed condition. So that preferred steps ratio is mentioned as basic series. So named as, for example, R5, R10, R20, R40, R80 and so on. Okay, and each basic series has a specific step ratio. Okay, so that its definition is given by Charles Renard. Okay, so preferred number are generally given standard. For example, R40. So this is equal to, R is equal to under root of 10 root of 40 under root of 10. So your value will be 1.06. So you can find out R40, R20, R10 and so on. So these are fixed values. Okay. Next is your harmonic progression. So what is harmonic progression? Harmonic progression is if, for example, there are number of speed steps. Okay. So for example, N12, N10, Nz. Okay. So if C is your difference between any two reciprocal of two numbers. For example, for N1, we will reciprocate and we will get it 1 upon N1. Similarly, second number is N2, so we will reciprocate it and we will get it 1 upon N2. Okay, so difference between any two successive numbers or reciprocals of number will be constant, so that is known as your harmonic progression. So by using this relation Nz, speed of class Z, you can find out N minimum divided by 1 minus Z minus 1 multiplied by C into N max, or you can say that maximum speed. So by using this relation, you can find out different speed steps. Okay. Next is this is your comparison between arithmetic progression, geometric progression, and harmonic progression. So first is your what is definition. So we have seen that in arithmetic progression, difference between any two successive spindle speed is constant. In geometric, ratio of any two successive speed is constant. In harmonic, the difference between reciprocal of any two successive speed is constant. Okay. And what is the zth spindle speed? So in that case, you can find out zth is N maximum. So N max is equal to this way. This was the relation we have obtained. It is equal to N max minus N min divided by Z minus 1. So by changing the parameters, you can find out N maximum. Similarly, this is the relation. Speed ratio is equal to N max divided by N min ki power 1 upon Z minus 1. So you can again find out N maximum. Similarly, in case of harmonic spindle speed. Okay, so what is the main application good in? Okay, so these arithmetic progressions are generally good in high spindle speed range. Okay, geometric is also good in high spindle speed range, where harmonic progression is generally good in low spindle speed. Okay, and these arithmetic progression poor in low spindle speed range. Geometric progression is also poor in low spindle speed range, but in case generally we prefer to use the geometric progression in low speed range also. Okay. and his harmonic progression is poor in high spindle speed range. So this was the comparison. Okay, thank you. So keep watching. Thank you.